Hi, this is Chris from FRC Team 3814. So, what is the purpose of 3D printing? 3D printing makes it easier for designers to create complex designs, and unlike with traditional processes, 3D printed parts and prototypes can typically be produced in hours rather than days or weeks, which allows companies to move through design cycles much more quickly and efficiently. So the way that 3D printers work is that they will print your design in layers so that there's less material wasted and the product will be faster. TinkerCAD is an online cloud-based program that you can use to design parts for 3D printing. TinkerCAD can also be used for creating and testing electronic circuits and for writing code. First, you want to head to tinkercad.com. Then you'll want to hit Create New Design. Up in the top left corner, it may create some silly name for you. So you'll want to rename your project. So a good way to name your projects is to use your first name and your last initial and then the name of the project. So my name is Chris H, and if I'm making a name tag, I'd call it Chris H name tag and then hit enter to save it.
Thanks, Chris. I'm Xavier, and what we're going to do first is talk about some of the key terms and key features that we're going to need to use in TinkerCAD. Once we're in TinkerCAD, we'll be presented with this wonderful menu. Now, some key terms are the work plane, which is what we'll actually do and put stuff on, and that's right here. The grid, which is on the work plane and helps us align our parts. The view cube, which is up here and allows us to figure out and also drag around to change our view. The home button, for in case we get somewhere where we're not actually able to see our part correctly and want to reset. Our toolbox, which allows us to actually take the parts and put them onto the work plane. Our group and ungroup tools, which allow us to take multiple parts and convert them into one. Our flip/mirror tool, which allows us to move parts and their orientations. And finally, the align tool. This allows us to take multiple parts and align them so that they're in however we want them to be aligned. Please note that for this video, we're only going to be using the waffle mode or 3D design mode, not the Lego or Minecraft modes. This video is going to be based in millimeters. So to make sure that you are set in millimeters, you can hit Edit Grid and then make sure your units is set to millimeters. So here's how you actually move around in TinkerCAD. To orbit or move around an object, you can use the view cube, or you can right-click with the mouse and drag, and that'll also move your view. To zoom, there's 3 different ways. You can use the plus and minus keys in TinkerCAD, the plus and minus keys on your keyboard, or the scroll wheel on your mouse. Like I said before, if you get in a weird angle where you don't really know where you are, you can hit the home button to get you back to this known location. Lastly, if you don't see the toolbox and it may look something like this, here there's a little caret that you can click on and it opens up your toolbox. Now let's get on to making shapes. First, you may see there's a difference between all of the different shapes and their whole counterparts, which only, in this case, the box and the cylinder have a whole part. That doesn't mean, however, that other shapes are not able to be used as wholes. So in order to create a shape, we need to first take a box, in this case, from our toolbox and drag it onto the work plane. We can also drag multiple of these shapes out to create a multi-shape structure. We can also delete shapes just like it is a file on your computer. Now, in order to resize the shapes, we click the shape, and then there will be these boxes in the corners. You can then drag on the box, click and drag, and resize it. If you want a specific dimension, you can click on the number and change the dimension. You can also do this in the vertical axis, except it won't be in the same as the linear X and Y axis. You can just take the vertical one and you can do the exact same thing. Now, we're talking about X, Y, and Z axis. What does that mean? So in 3D printing, there are 3 axes compared to just standard printing where there's only 2. We have the standard X and Y axis, which we have Y and X. And then we also have a Z axis, which is our vertical axis. Now it's your turn. Let's take out a box. And let's say we want the box to be 30 millimeters by 30 millimeters by 5 millimeters thick. We can take the box and we can set it to 30 millimeters. So just by clicking here, we can click 30, and that is our y-axis. 30, that is our x-axis. And 5, and that is our z-axis. Now, let's say we want to create a hole in the center of this. There's 2 ways of doing that. We can either take one of the hole tools, or we can take any object that is an actual solid and turn it into a hole. So take that object, drag it out onto the work plane, and then over here, there will be a shape bar. If it looks like this, all you have to do is click this drop down, and it'll allow you to get access to more features. Click hole, and there we have a hole. Well, not really. We still have to figure out how to create this into a single object. What we do is we will select all the objects that we want to group together, in this case, just our box and our cylinder, and hit the group button. It may take a bit, but eventually it will create a hole or group the objects together if you're not trying to make a hole. Let's say we wanted to move this around or resize it. We can then ungroup the object and we can move it. Select them both, and we now have a hole somewhere else. Now let's get into a very basic project, which is creating a name tag. What we're going to use is some of the things we've learned before, plus the text tool. The text tool, you drag out, and again, if you don't see all the advanced features, click the drop down. You can then change the text, so we'll name this our robotics team's name. We can change the font between 4 different fonts. We can change the height of the shape, and we can change the bevel and segments. Bevel is the thickness of the outline, and segments smooth the edges. Now let's turn this into a name tag. We want to make one that's a box, so we'll take out a box, we'll resize it, and now we can drag our text onto it. By holding Shift, we can make all 3 dimensions become proportional to each other while resizing. We can also change the colors if we wanted to. However, when we group them, it will take only one single color because it is now one object. Now that we have our design, we want to export it so that we can 3D print it. What we can do is we can hit the export button over here, and that'll allow us to 3D print it, or if you're doing laser cutting, laser cut it. Now, if we wanted to only export one part, we would simply have to select it, but we want to export everything. So we click Include Everything in Design, and we can export it as an STL file. If we want to have it printed by someone else, there's different links to different companies that may be able to 3D print your design. Now that we have our design exported, we need to set it up for 3D printing. What we need to do is open up our slicer. Our slicer is what takes our STL file and converts it into the code that our 3D printers can understand. In this instance, we're using Ultimaker Cura. In order to use this, we need to first import our STL. We go to File, Open Files, and then we go to where we downloaded it. In my case, I have it on my desktop. Now that we have it in, we can use our mouse so that we can inspect it. And that looks good. Over here, we have our print profiles. I already have mine set up for 0.3, but if you don't have it, you may want to adjust some of your settings, such as layer height, shell thickness, infill, material, and your speeds. In this case, we're going to be using 20% infill. This is what it looks like while 3D printing. As you can see, it's very important that because layers stack on top of each other, nothing is floating in midair. This allows our prints to be made successfully. One way to help with top layers is by having infill. If you want to have parts hanging in midair, you need to specially design your part so that way it'll allow for the 3D printer to easily transfer over these areas. Once you're all ready, hit the slice button. This tells me that it'll take 33 minutes and 16 grams of filament. Now all we have to do to get it into our G-code that our machine can read is hit Save to File and save it where we want it.
I'm Mackenzie, and if you're interested in learning more about our team, you can go to our website, pibotics.info, or our social media handles, Facebook, Instagram, and Twitter at Pibotics FRC 3814.
Who are we? 3